I'm like doing it wrong, I'm just like.
You'll do good.
It's pretty easy.
It depends. If you are good at factoring like regular numbers like 15 and 25, people tend to find this factoring also simple. But if you have a hard time factoring down regular numbers, then sometimes it can be more difficult. But all right, guys, you should be on these notes, P5 extension. One thing to be aware of, if you're using the paper copy notes, there are colors on this notes and they are given to you on purpose. So maybe just recognize what colors are up on the screen and I'll show you kind of what they're for. So if we start right away, oh, Alyssa, mine went out and yours, is yours okay? Mine went out at the same time. Olivia, are you still with me?
Yep, I'm here.
Sorry, my thing went out. Me unvideo that. Okay, unfortunately, I can't see. Oh, I can see you. Okay, awesome. Okay. So guys, you just did this on your bell ringer. X plus 2 times x minus 2. You FOILed that out. You had x squared plus 2x minus 4. And what did it simplify to? Good, x squared minus 4. Now, number 1 has the same color as number 5. That's on purpose. Same on purpose. I have color coded this notes to hopefully help you recognize some patterns. So looking at number 5, number 5's directions are factor the following. Factor basically means to unmultiply. Let's go back to a basic example before you. Right. Well, let's go back to a basic example just so we make sure we know what factoring means. If I ask you to factor the number 15, you guys had to do this with the radicals. What did you factor 15 down into? 5 times 3, right? So 15 would factor into 5 times 3. Notice factor just means unmultiply. Bring it back to where it came from. So if I'm asked in number 5, x squared minus 4, like unmultiply it, yeah, I'm going to go back to what I did in number 1. Number 1, that was the result, x squared minus 4. So I know where it came from, x plus 2, x minus 2. So I'm going to go ahead and copy that back down. It came from x plus 2, x minus 2. And that would be my answer. All right, number 2. First, number 2, turn to your partner and ask them, what are they doing after school today? Olivia, what are you doing this afternoon?
Really nothing.
Yeah. I am supposed to have my kindergartner's baseball game, and I'm wondering if it's going to get canceled because how wet it is outside.
Yeah, because it rained.
So we'll see. I love watching him play baseball, but it would be really nice to relax on the couch. So part of me is kind of hoping that it gets canceled, but we'll see. All right, guys, out of you and your partner. Out of you and your partner, whoever has the most going on tonight, you go ahead and relax. Let your partner do number 2. Number 2. So Olivia, I guess that maybe you, I don't know. What would you multiply 2 to be?
So, this one is not factoring. Oh wait, no. Which one are we on?
This one's not what?
Are we on the bottom ones or no?
We're on number 2.
4?
Number 2.
Okay. So I got x squared
Awesome.
minus 3x plus 3x minus 9,
Awesome. And what happened to the middle ones?
which then they cancel out. So it'd be x squared minus 9.
Awesome. You're amazing. Thank you. All right, guys, you and your partner should have gotten x squared minus 9. Let's see if we can then go to the color coordinated one, number 6. What do you think x squared minus 9 factors down into? Good, x plus 3, x minus 3. Okay, let's go on to number 3. Number 3, what does number 3 multiply into? Squared minus 25, awesome. So let's go to the color coordinating one, number 7. What does x squared minus 25 then factor down into?
X plus 5.
Nice. X plus 5, x minus 5. And then did I throw in a ringer like I did on the bell ringer, or does this match the same pattern? Number 4. What does x plus 6 times x minus 6 multiply into? Ah, so this one was not a abnormal one. It did have a plus and a minus. And it does color coordinate with number 8, which means that x squared minus 36 factors down into what? Good, x plus 6, x minus 6. Now, ultimately, you don't want to multiply every time and then factor it back down. You want to have a rule that will help you. If I'm given numbers in this format, just factor it straight down. So focus in on numbers 5 through 8. What do you notice about all of the values like x squared and 9, x squared and 25, x squared and 36, or x squared and 4? What do you notice about those values? John?
They're all like plus and minus.
Oh, so John noticed that when they factor down, they turn into a plus minus. And why did you say that, John?
Because there was always.
Ah, there always has to be a negative for it to cancel. Love it. So when you factor it, it always turns into a plus minus. So if I'm looking at the rule for factoring the difference of two perfect squares, I can use what John just told me. I know that when I factor it, there will always be a plus and a minus. The other piece that I recognize is all of these. Let's just focus on number 8. Sometimes when there's so many, it can be hard to zone in on one thing. If I just focus on number 8, x squared and 36, I want you to recognize that they are both perfect squares. X squared is the result of x times itself. 36, what would be the square root of 36? 6. So 36 is the result of 6 squared. So both of these are perfect squares, and that's important. And all of them have to have a minus sign in between. Notice that their square roots, x and 6, show up in the parentheses. That happens all throughout this first page. So the rule that will work for any number, we use a and b to represent any number. If you have one value squared, so one number squared, minus another number squared. So in this case, they say if you have a squared minus b squared, it's going to factor into the sum of their square roots. In other words, parentheses a plus b, and the difference of their square roots. In other words, a minus b.
And this is always the case?
This is always the case if they match this pattern.
If it's like a perfect.
If it's a perfect square, exactly. So let me give you another example now, and this time I'm not going to have you multiply anything. I just want you to use that rule to factor it down. If I ask you factor x squared minus 144, see if you can do that. See if you can factor it down using that rule. Turn to your partner and see if you guys got the same answer together. Olivia, did you get it?
Would it be x plus 12
Nice.
and then x minus 12?
Awesome. And you were able to determine what A and B were. Well done. All right, guys.
13 would be like.
169.
Oh, I said 196. That's 14, right? 14 is 196.
Yes, you're right. Okay, so you should factor down into x plus 12 times x minus 12. Now, I want to expand on something Haley said. If you were asked to factor something like this, x squared plus 144. Good, Caroline. This one, well, there's nothing you can multiply that will bring you back to this. So this doesn't match the rule because it doesn't have a minus sign. So I would say this cannot be factored. Just like the number 11 can't be factored, it's prime. In the same way, there's certain polynomials that cannot be factored, they're prime. So the piece to be aware of is it does have to match that format. Any questions on that first page? All right, back page. This one here, if you have a distraction out, if you could put your phone away, I know it's the end of the day, this backside's a little bit harder to grasp, so I really need your focus up here. These colors do coordinate. It's on purpose again. Number 9, you're asked to multiply. We did that a lot in last night's homework or in Friday's notes last week. How do we multiply something like this? Good, distribute the x and distribute the +3. The method we used on Friday, if it was helpful to you, is to rewrite the trinomial twice, or you could distribute in your way as long as it always works out. So I'm going to use the method we looked at on Friday, recopy that trinomial, and I'm going to distribute. So distribute the x to every piece, and that gives me, what is x times x squared? X cubed, good, I'm here, want to make sure we have that. X cubed minus 3x squared, good, plus 9x, good, plus 3x squared, nice, minus 9x, plus, what's 3 times 9? 27, nice. And finally, I'll add up all my like terms. X cubed is the biggest, so that will stay. What happens with the negative 3x squared and the positive 3x squared? Cancel. How about the 9x and the negative 9x? Cancel. So all I'm left with is positive 27. So let's write that. The answer to this is x cubed plus 27. Now, obviously, the colors coordinate. So number 11 is meant to have a correlation with number 9. Number 11's directions are to factor. What does it mean to factor? Break it down. Yep, unmultiply it. So x cubed plus 27 is the result of what I got when I multiplied. So if I factor this down, really what I need to do is copy what I multiplied. So I'm going to copy down x plus 3. I'm going to copy down x squared minus 3x and copy down the plus 9.
How are you able to determine like,
What those will be if we
Yeah.
didn't have it,
yeah,
we'll talk about it. But you do want to be, let's see if we can notice anything. Do you notice any correlation with 3 and 27?
yeah.
Allison? Yeah, raised to the 3rd power. So if I took the cubed root of 27, I would get 3. If I took the cubed root of x cubed, I'd get x. At least that first parentheses kind of matches what we saw. The second one's a little bit more wacky, but we'll see some patterns after we do a few.
Also be like, for example, like in the parentheses, what if it was just three of these?
Unfortunately, if you multiplied x plus 3 times x plus 3 times x plus 3, so I know what you're thinking, like, is this, whoa, stop. You weren't thinking that. If you're probably thinking, is this
Oh, right, because it's
the same as this? And it's not, because if we multiply this out, you guys did that on your bell ringer, it's x squared plus 6x plus 9. So it's not the same as this. So that's a really good observation to make. I can't just write this as x plus 3 times x plus 3 times x plus 3, because it's not the same. It won't multiply to be that.
I was thinking of just having that bottom part and then just multiplying with it, that's not factoring. Or do foiling.
Right. All right, guys, number 10. Number 10, the person who didn't talk first in the group last. You turn to your partner and tell them what you would do for number 10. All right, Olivia, that's me. Let's see, I would distribute the x, distribute the 4. I would copy everything from here twice. X squared minus 4. You just go quickly because we're gonna learn stuff soon. Okay. X cubed minus 4x squared plus 16x plus 4x squared minus 16x plus 64. Sorry, I wrote pretty fast. Are you doing the same?
Yeah, I'm writing it.
Do you notice that all of these guys cancel?
Mm-hmm.
So we get an answer of x cubed plus 64. All right, guys, bring it up to the front. Hopefully you noticed, wow, all of those middle 4 terms canceled again. And we got an answer of x cubed plus 64. Let's see if our patterns that we observed, at least so far, still hold true. Is 64 a perfect cube? Yeah, what number times itself gives you 64? 4. Okay, so if we go to number 12, I know it correlates with the same color, number 10, but if I didn't know that, I still have that x, which is the cubed root of the first one. And I still have that 4. Should be a 3, and that looks like a 9. So x plus 4, that is a factor. The next factor, this one's a little kookier, so I'm just going to copy it straight down for right now. X plus 4 times x squared minus 4x plus 16. That's what I multiplied to get x cubed plus 64. So that's what it would be factored. All right, let's keep doing some problems to see what patterns we're observing. So number 13, on your own, go ahead and multiply that out. Okay, you might have multiplied it out. You might have looked at number 15 and said, I know what it's going to be. But if you multiplied it out, that's good practice because on the quiz on Thursday, you will definitely have one like this that doesn't work out so nicely. So you have to know how to multiply a binomial by a trinomial. Now, obviously, number 13 came out to be x cubed minus 27. 13's color matches which one?
13, 15.
Good, 13 matches 15. So let's factor x cubed minus 27. It would factor down into, I'm going to copy what I multiplied. X minus 3 times quantity x squared plus 3x plus 9. Number 14, what do you think 14 will multiply into be? What do you think its answer will be? Number 16's answer, you are correct. So I'll just go ahead and write it. This is what it will simplify to, x cubed minus 64. So number 16, what do you think it will factor into be?
The same as 13.
The same as 14, so we'll copy that down. X minus 4 times quantity x squared plus 4x plus 16. Alyssa. My Zoomer, yeah, she came back on, so I'm assuming you have a bad connection. Are you back with me, Olivia? Thank you, Alyssa, because I lost her one day. Olivia, are you with me okay? She has thumbs up now. Thank you. Thank you for checking on that, Alyssa. So guys, we have all of this multiply, unmultiply. Let's see if we can figure out some patterns in what's happening. First thing to make note of is what you guys have already seen. These are perfect cubes. This one was x cubed. This one, what times itself gives you 64. 4 cubed, good. This one was 2 perfect cubes. This was x cubed. This was what times what gives you 27. 3 cubed. Okay, these rules that we're going to learn are called the difference of cubes and the sum of cubes. Mario, do you notice something else?
I was gonna say, if the x is cubed, does that mean that the number is always cubed? Or
Not-
would the number be squared?
The number next to it?
Yeah.
If the x is cubed, you want to check that the number next to it is also cubed. Otherwise, it can't be factored in this way. So Mario's noticing that A and B, both of those two numbers have to be perfect cubes.
So what she asked
Was true if it matches this pattern. Yes, it has to be cubed. Yes.
only if
It can
matches,
be
like,
unsolvable. It
perfect
could be
cubes
prime.
or perfect square.
Yes.
Okay,
Yes. They either have to both be perfect squares or both be perfect cubes.
so it's like same thing for like number 9.
Number 9. Yeah. Number 9
Perfect
is
square.
also 2 per number 11, which matches,
Yeah.
is also 2 perfect cubes. Now I
But on the
do
previous page, it was perfect square.
perfect squares. Awesome. Okay, if we're looking at like number, you can choose any of them. Let's choose 15. Notice where those cubed roots show up. So let's just focus on the x. Notice when we factored, we had an x in the first parentheses. We had an x times itself in the next parentheses. And then you always had one x in the middle. If I look at the next number, 3, I had a 3 in the first parentheses. The 3 shows up in the middle. And how can 9 relate to 3? 3 squared, awesome. So that seems to have a pattern. You have the one cubed root, that cubed root squared, and that cubed root in the middle. You have the other cubed root of 3, it's in the middle, and then it's squared. Let's see if that pattern showed up in number 16. If I look at x cubed minus 4 cubed, I had an x, I have an x here. I have x times itself, and I have an x here. If I look at 4, I had 4 here. I had 4 here. And wait, how does 16 relate to 4? 4 squared, good, 4 times itself. So the pattern that works for the difference, and if you looked at the sum, you would see the same thing. The a's and the b's will have a pattern to them. If you have a cubed minus b cubed, you do have to know what is being cubed. So what's representing a and what's representing b. But the position that you put a and b will match in both situations. If you have a minus in between them, you are still going to have a binomial times a trinomial. You will have a and b. You will have a squared and you will have a b squared. And you will have the two smushed together in the middle, a times b. The same pattern will show up in the sum of 2 cubes. So I haven't written the signs in yet. I'm going to show you the signs in a moment. So right now, just know this is unfinished. But if I go to the sum of 2 cubes, I still have to recognize what's the cubed root, what in essentially is being cubed, what's acting as a, what is acting as b. But once I know those, the a and the b is going to match the exact same pattern as the one that I just wrote down. So I'm going to have an a, I'm going to have a b. I'm going to have an a squared, I'm going to have a b squared. I'm going to have the two multiplied together in the middle. The signs. Now we have to look at the signs. So remember, I said these are unfinished. So let's go back to the difference of cubes. Here's how the signs work. If what you're factoring is a minus, the first sign that you factor will be the same. It'll be a minus. In fact, I'm going to write that. It's going to be the same. And I'm just going to say sign as beginning. You're like, what do you mean as beginning? As this one right here. The next one's going to be a plus. That's not the same, so I call it the opposite.
Why will it be an opposite?
It's the way that it factors down. So if you look at the patterns of, hey, what was multiplied? Like if I look at this one right here, it was a minus, it was a positive, and then this one is always positive. So the,
Always that way?
yep.
Okay.
And the last sign is always positive. Oh, so exactly right. That's the acronym that I use to help me remember this. Same, opposite, always positive. Mario already noticed that acronym. Now, if you can remember that acronym, it works the same exact way as the sum of 2 cubes.
So if the center one was a positive, it'd be a minus baby.
So if I'm looking at like the sum of 2 cubes, if it starts off as a plus and that's what you have to factor, then it starts off as a plus. So it's the same as,
A minus.
yes, you're saying the middle one, yes. And then that one's going to be opposite.
And so always applies. to these.
Yep. And this one's, yep, always positive. Yes. So if you notice like Mario did, you have 2 perfect cubes. If you're factoring the sum of two cubes, the A and B positions, you just kind of have to memorize those. Those do have to be specific. But then the signs, an acronym that I used to remember is it's always the same as what you came with, opposite and always positive. Caleb, can you do this one practice problem? And if you get it, I'll say go. Okay, now if you don't get it, then I'm sorry, you have to wait one more minute. Okay, here's what I'm gonna ask you to do now. I have not given you this example. You have to use the rule, so I haven't given you this to multiply out. But I'm basically looking for, can you use this rule? So now, if you're asked to factor x cubed minus 125. I'm going to show you how to do it in a moment. Caleb, can you tell it to me? You don't have to write it. Can you tell it to me?
It's x minus 5, and then you're gonna do x squared plus 5x. No, plus 6.
6. Where'd you get 6?
It's 5. 10.5.
There you go. Okay, go ahead. You're good. All right. So if you heard what Caleb said, he first found the cubed roots. He knew that this guy was x being cubed. He knew that this guy was 5 being cubed. Then I actually like to write it before I say it, because I write it in the same way that I showed you guys above. I write down A and B. So in this case, A would be x, B would be 5. I write down A squared and B squared. So I write down, in this case, x squared and 5 squared. I smush them together in the middle. So 5 times x. And then I use soap to clean it up. The first term is negative, so it's going to be the same as what we started with. So what's the first sign going to be?
Subtract.
Yep, the second sign is opposite, and the last one's always positive. So that's it. You factored it down. Now, do we really write 5 squared in that way? No, we usually write it as 25, but that's essentially what you'll see. Any questions on that? The quizzes tonight will be doing these two things. Quizzes. So the homework tonight is through the Quizzes app. You can take it as many times as you want to get the homework score that you want. I personally would have my notes next to me because these rules are new. And the goal tonight would be, can you use these rules like we just did? I also, if you didn't quite catch those rules, I did copy the ones from your book that the quizzes will cover. So it's the difference of squares and the difference and sum of cubes. These two rules right here, I'm not going to have you memorize, but they're helpful to know. And some of you might even already know how to work with them. But the quizzes will only have those two that are starred. I do have to ask you some questions in the more discovery. Sorry? The two that we just covered, the difference of squares and the difference in sum of cubes. Now, there's a little bit of more discovery, but before we do this, I have to ask you a question. Oh, that would be a good question. It's not the one that pertains to this notes though. But x plus 2 squared, does this equal x squared plus 4? And this equal x squared minus 9? And this equal x squared plus 25? No, that's the most common algebra 2 error. Don't make it. What do I have to do instead? Foil it. Now you might notice a pattern when you foil the same thing, the same number times itself. Because the first one is x squared. Outside is 2x, inside is 2x, last is 2 squared, which is 4. So the middle, or this simplifies to x squared plus 4x plus 4. Let's foil the next one and see if we see a pattern. So I have x minus 3 times x minus 3, and I foil, and I would have x squared minus 3x minus 3x. What's negative 3 times negative 3? Close. Positive 9. Good. So we'd have x squared minus 6x plus 9. Let's do one more. Letter C. Or maybe you already see the pattern. Does anyone know what C already will turn out to be? x squared plus 10x plus 25. Caroline, how'd you do that so fast? What did you see? Oh, you're
But you can also tell because it's x squared and then it would be, the number times two.
the number times 2. Awesome. Good. So that middle one, notice 5x, this is 10x. Notice 6x, that's 2 times 3x. And this one, 4x, is 2 times 2x. So if you see that pattern, it can just be less work to multiply. And that pattern is in your book. It's here. You don't have to have it memorized. You could FOIL every time. Letter D, is this equal to x cubed minus 27? No, do not. Never, ever, ever. No distribute. That doesn't even make sense. It's the end of the day. No distribute. Do not distribute to terms. Only factors. You guys have a great day. Homework is quizzes. And have a good afternoon.